Hello, good morning, good afternoon, everybody, wherever you are. Welcome to this webinar from Versa, the topic of which today is satellite networking enters the mainstream with SD-WAN. I'd like to just kick off briefly by introducing Shitresh, my colleague, and myself, Tony Fallows. Both of us are with Versa and have focused on developing the satellite market over the last 6 years. And today we want to share with you some of the experiences and some of the trends that we're seeing in the market. So satellite enters the mainstream. There are 8 takeaways I want to just discuss with you very briefly. The future outlook is shifting to be less geo in the satellite world. Analysys Mason, an analysis company, has predicted that the current capacity of geo in space is 21%, and that will be, the non-geo capacity in space is 21%, and that will increase to approximately 50% over the next 6 to 7 years. So the future is definitely shifting to a LEO and a MEO architecture. Also, the role of satellite is changing. Satellite today is used predominantly for 2 use cases, either in very hard and remote, difficult to reach places, or for mobility related use cases. So for planes, trains, shipping, etc. The role is shifting to one of being for a primary connectivity, for a broadband in the sky. And whereas even as recent as 12 months ago, there was a lot of discussion as to whether the future was going to be LEO or GEO, most organizations now are investing in both and investing in multi-orbit, multi-path based services so that they can offer a more diverse service offering, both with GEO, MEO, LEO, and combining and blending those with 4G, 5G, even terrestrial networks to get a fully software-defined multi-orbit, multi-path capability. Now, these capabilities are taking advantage of technical advancements that were made from SD-WAN that we've seen over the last 6 or 7 years being adopted for branch connectivity. So capabilities such as fast traffic steering and application-based SLAs and increasing the security on the edge of the network. These advancements are now being adopted by satellite service providers to provide this next generation of multi-orbit, multi-path capability. And that multi-orbit, multi-path capability means that even with failures, that the achievement of 100% is feasible. And that's really driving the adoption now for greater demand. So a higher performing, lower latency, more reliable satellite infrastructure is driving market opportunities and new use cases. So where we've seen traditionally government operations, military, oil and gas and wind, even telco backhaul adopting satellite cases, they are evolving now to those use cases to be multi-orbit. And we're even seeing adoption within segments that weren't traditionally adopting satellites. So for example, we are seeing adoption within the satellite, within the retail space for replacement of LTE backup services with LEO-based services. So these are some of the sort of key takeaways that we're seeing, the trends that are being adopted within the industry. And just want to pass over now to Shitresh, who will provide a bit more detail around these capabilities.
Thank you, Tony. So while Tony covered the market trend that has been changing in the last 4 or 5 years, where more and more adoption of non-geo where satellite connections are gaining traction in the market, there are challenges when we move the connectivity or we use connectivity over satellite. Before we go into the technical details of how SD-WAN can help there, let's go into the challenges that market faces or the satellite-based connection faces with the connection over there. So first of all, the latency. As you know, the round-trip delay between the device and the satellite and back into the ground station is very high. any latency sensitive application may not perform as good as it would have performed over the wired network or over the 4G 5G radio network. So latency is a big challenge when it comes to the satellite based connectivity. With MEO and GEO network being adopted, some of these challenges are not there or maybe reduced in compared to the GEO, but it's more than what a wired network or a radio network could provide. The second challenge that we see is that when devices are moving, for example, ships or the planes, they go through different type of weather conditions, different challenges when it comes to connecting to the satellites. And because of those challenges like coming through the cloud or rain, the throughput and latency increases for those devices. Since there is a high cost of deploying satellite, launching, building, and sending to the sky, the cost of this service is also very high, and that is why market could not adopt the satellite based connection for some time. And with new advancement in technology, that cost has been reducing, but still very high compared to the wired network or the radio based networks. Degradation of services over time when the weather conditions are changing, that affects the services. And because of that, we need to have some solutions which can dynamically adapt to the ever changing conditions of weather and dynamically adapt to finding a better way to connect to different satellite or move into a different SLA which can be better connection. While Tony mentioned that we see enterprises and users are making use of multi-orbit connectivity, where it could be combination of LEO, MEO, and GEO satellites simultaneously connected, or multiple orbit circuits connected at the same time. There has to be a technology which can make users actively use the circuits based on the application performance and the SLAs available for each network connectivity. Bandwidth is another challenge because the bandwidth over the satellite network is limited. We need to make sure the applications using the satellite based connectivity are properly routed to specific type of satellite connections, whether it is LEO, MEO, or GEO, because while LEO can provide much better throughput, GEO may have some bandwidth limitations, but it may have guaranteed service. In order to provide the combination of LEO, MEO, and GEO, we need to have a mechanism to properly choose the application which can go over a specific type of links, because LEO can have lower latency, GEO can have higher latency. We need to make sure while we are using the bandwidth properly, the applications being used should be properly chosen in order to make use of a specific link. So some of the key features in the satellite context that the SASE features that we have seen in the market that has improved the services over the satellite-based connectivity. One of them is the class of service. While class of service is always known in the routing domain, there is a specific use case when it comes to the satellite-based connectivity. Since we are making use of different type of satellite connections with different latency, different bandwidth, if we are using multi-orbit circuits simultaneously, there has to be an app-based quality of service, which requires identifications of different type of applications and associate those applications for the SLAs required for that. Once we identify the application quality SLA, we provide the linkage of that application to a specific satellite link. For example, if you have a audio and video application, it may be better suited for Leo, while other non-latency sensitive applications can be routed via Geo. At the same time, if there is an issue on a particular satellite link, the app cost should make a decision which application can be prioritized over other applications and make use of the available bandwidth at that particular time. Hierarchical quality of service or class of service is also very important when you're using the satellite links over multiple different uh, customers on the other end, where each customer can be given specific bandwidth. It should not happen that one particular user is hogging the complete band link and starving other users. If there is available bandwidth, we should prioritize the applications that is requiring specific bandwidth. Implementation of granular cost is important in this case, since bandwidth is uh, the cost of bandwidth is very limited here in case of satellite. Going all the way to the device level or a particular user level, and then identifying the applications requiring a specific connection. We need to have a capability where you provide limited bandwidth for a particular user and only make other bandwidth available or the link available if it is not being used by other users or other customers. So all in all, quality of service over different type of SLA based applications over different latency sensitive links is very important for the satellite connections. The second part is traffic engineering. While it is easy to measure the SLA between two hops, end-to-end SLA measurement is very important. Reason being, why one device using the satellite connection can connect to the ground station, it may not be the optimal route to go to the end application. When we measure end-to-end SLA, it can find the better path to reach to the end application, maybe using a different ground satellite ground station. That's where end-to-end SLA measurement is very important, not only from the hop by hop connectivity, it also should to have a mechanism to measure the performance of the end application. So while the end application server may be reachable, it may be backed up and it may not be performing as per the requirement. And dynamically, user should be able to be moved from one path to another path. As I mentioned earlier, the bandwidth is very limited in case of satellite. We have to have a feature which basically can compress the overhead or reduce the overhead by compressing the header. The overhead could be in form of SD-WAN tunnel or IPsec tunnel or any type of tunneling mechanism that you use can cause more overhead over the satellite links or any other SD-WAN links. So header compression and tunnelless SD-WAN mode is very important feature. While different weather conditions can degrade the services, it could also cause retransmission and causing overhead in while the applications are dynamically shifted. Having forward error correction or packet replication can improve the quality of service in bad weather conditions or when SLAs are not met. But important thing here is that while in a sunny day scenario, when the satellite links are working as per the SLAs, we should not be taxing it by statically configuring the forward error correction or packet replication, because both of these would add extra bandwidth for the application. So the important thing here is that while these traffic conditioning features can improve the quality, it should be activated only when the SLAs are not being met. Second important aspect of traffic engineering is not only monitor the routing path, it should also be able to monitor the end application connectivity and performance so that you can choose the right application server over a right path for better user connections. Since satellite-based connections are latency sensitive, as well as like the latency is higher on the satellite connections, there are various WAN optimization techniques have been developed to mitigate those issues. And depending on the latency, whether it's a geo with high latency, while LEO has some latency, but it supports higher bandwidth, different TCP optimizations protocols have been developed. When a user is the user packets are moving from one link to another link, or when you're using two different type of satellite links simultaneously, there has to be a mechanism where, depending on the link type or the satellite you are using, you should be able to dynamically select the better suited TCP optimization or the buffering and congestion control protocols based on the type of link that you're choosing. For example, the geo links for geo satellite connections, Hiblock would be a better suited optimization technique, while for LEO, it could be Cubic or any other TCP congestion protocol. In case we are splitting the applications, some applications are going over geo, some applications are going over LEO at the same time, based on SLA measurement and the TCP optimization protocol that you are choosing, we need to have a capability to simultaneously segregate the traffic and make use of everything that is available to the end user. Security is becoming very important, but at the same time, security requires different appliances to be put at the end user, whether it's a ship or a plane or a moving train, where the real estate may not be as big as that we may require. In that case, there has to be a capability where you can pick and choose what type of security you're putting at the end user device connected over satellite versus the ground stations. Having security both at the end user device as well as the remote ground stations is very important. At the same time, having a operating system or a solution which can provide not only SD-WAN connectivity, but built-in security is very important because it can reduce your real estate required for that particular service. And at the end of the day, you need to have a hardware flexibility where you would like to reduce the hardware real estate at the locations where you're deploying the service. Now, coming to the traffic engineering for multi-orbit circuits, application traffic conditioning requires identification of application. At the same time, based on the available link, solution should be able to do the weighted load balancing depending on the available bandwidth and SLA at that particular moment. This load balancing should be transparent to the end user so that in case one particular link goes bad, it should be seamlessly moved. Application should be seamlessly moved from one link to another link. At the same time, there should be a capability not only to identify the application, but depending on the network SLA, there should be a decision which application can be routed on a which type of circuit. What we have seen in the market is that while the satellite terminals have capability to understand the SLA at real time, it is not integrated with the SD-WAN solution. So having an integration with SD-WAN orchestrator and controller and getting a feedback from these terminals to make the decision is very important feature. There should be a continuous monitoring of bandwidth, latency, jitter, error rate, packet loss using smart probes. Typically, the ITOT why 1731 protocol is used for monitoring. For audio and video, MOS scores are very important to measure the quality, and based on the MOS score on a specific link, applications can be routed, audio and video applications can be routed over different circuits. And as we discussed earlier, the traffic management should be dynamically changing based on the degradation, if there is, due to the weather conditions or any other issues in the satellite network. That network selection should take into account three different parameters. One is the applications being used, SLA required for that application, the network SLA, and the end application server performance. This requires adaptive shaping because while there are a large number of devices connecting over satellite to a particular ground station hub could still be backed out. In case all the devices are sending traffic to the ground station, it may be backed up, and there should be a communication between the two ends to do the adaptive shaping, where it should be able to tell the remote device that it can only take so much of load and not send more than it can chew. What it means is that both ground station as well as the remote device which is connected over satellite should be able to communicate to each other and understand how much of throughput or processing power available, as well as the link availability to send the data in both the direction. And that requires adaptive shaping on both the ends. So some of the key takeaway is that industry is moving to multi-orbit approach, and SD-WAN can be a solution to provide much better connectivity when you're using the multi-orbit circuits, where at the same time giving user a much better performance. Adaptive shaping, advanced traffic steering using application awareness, and TCP optimizations are very key feature to make use of multi-orbit circuits using SD-WAN. LEO is gaining market traction rapidly. Solutions should be able to provide connectivity over LEO as well as the other satellite links. We have seen the critical or essential services like maritime or first responder, oil and gas, and even in remote islands, the satellite being used for the cellular backhaul use cases as well. Tunnel-less SD-WAN is in demand, where we can reduce the overhead of tunnels or compression of the header used by the tunnels to reduce the overhead that is being required for the SD-WAN connectivity. Obviously, real estate is a very key feature for having a flexibility to use the hardware of your choice, whether it is the purpose-built hardware or the hardware which is already required by the satellite providers, to have flexibility to use SD-WAN as virtual machine or a container or a bare metal based, or should be deployed in the cloud. So with that, we will open up for questions.
Thank you, Shitresh. It looks like there's a few questions from Kevin in the chat window there. Maybe I'll take the first couple of those and you could address the third one. So the first question, what is Versa's market traction for both adoption and satellite provider partnerships? So as I said at the beginning, Shitresh and I and Versa have been focused on the satellite market for about 6 years now. There's a lot of very nuanced capabilities that we have developed for the satellite market, and because of that, we're having enormous success. Without naming names, 4 of the 5 largest satellite providers in the world have adopted Versa to provide managed services to their customers. And we're rolling out at a great rate and seeing uptick in the adoption of SD-WAN coupled with multi-orbit satellite. So the adoption is going very well. Do we support Starlink connections and Starlink network? The answer there is yes. As I said, the industry seems to have adopted an approach for multi-orbit that is including both GEO and LEO. Obviously, one of the most advanced and comprehensive, extensive LEO networks is Starlink. And so we're seeing uptick and adoption there across many different vertical markets. So maritime, for example, oil and gas, defense, and we've got many thousands of Starlink connections that are now enabled with Versa SD-WAN. Shitresh?
Yes. So do you support Starlink connections and network? Yes, we do support LEO, GEO, West connectivity, also the MEO connectivity, and Starlink being the LEO providers. We do support Starlink as one of the satellite providers, and we have deployment with some of our large enterprise customers where our SD-WAN solution is connected over the Starlink connections. Tony, you want to throw some light on Starlink partnership?
Not on this occasion at the moment. Okay. Thank you. Yeah.
And the next question is, what is Versa's market traction? And I think that has already been covered by Tony, that we have good traction in the market. Tony, anything that you want to address here?
No, as I said, I've addressed that one. If you could address the best practices question there.
Okay. What are there best practices or approaches when building and multi-orbit connections? Yes. So as we mentioned earlier, there are 3 different things that you need to make to keep in mind when you are building your network using different type of satellite connections. First of all, applications identification should be there on SD-WAN solution, specifically the SLA required for a specific application. Then have a capability to measure SLA over different type of satellite links. Once you have done that, then you can match what application goes on which particular link. That is one important thing. Second thing is the security. Each end device must have built-in security so that you don't need to have different security appliances where the real estate is very, very low. At the same time, you need more performance when you have when you have security built in. You can have much better performance and low latency with the integrated security. And the third one is having the traffic engineering features, which can be dynamically activated so that you're not statically configuring forward error correction or packet replication and unnecessarily taxing the bandwidth over the satellite connections. So there are 3 things: application-based SLA monitoring, connecting it to a specific link, and then traffic engineering features which can be dynamically used, as well as built-in security.
Yeah, thank you, Shitresh. So we're just coming up to the end of the seminar, the webinar here, and just remains to say thank you very much for joining us today and spending the time to learn about Versa in satellite. Thank you.
Thank you.